Now we will see these two trigonometric simple basic functions Laplace transform, sin t and cos t. Let's break down the sin t function at the term of exponential function. If we break down this sin t, then we'll find the exponential function as e to the power it minus e to the power minus it divided by 2i. We got this from the equations of e to the power xt or something, it or something like this variable. So at first we will break this sin t into the e to the exponential functions. So let's write down our basic formula of Laplace transform. It will be integration of 0 to infinity. Our f of t means sin t and e to the power minus st dt. It is also a function of variable t, so we integrate this at the term of t. Then we will break this sin t into our exponential term. So integration of 0 to infinity e to the power minus st. At first we write down this term, then we will break this sin t, which is equals to e to the power it minus e to the power minus it divided by 2i dt. So we will multiply these two exponential terms, and as this 2i is a constant term for this function, then we will remove this from our limiting value. So we will use the third bracket, is integration of 0 to infinity. At first we multiply this with these terms, we will get e to the power minus, we will took the t as a common, so there remain s minus I into t dt minus integration of 0 to infinity e to the power minus s plus I into t dt. We just multiply this term with this exponential term and we will find two terms as there is a subtraction, so and we'll divide the limit for those terms separately to understand the calculation easily. Now we will put the limit, integrate this and put the limit in this function. So if we integrate this term, we will get e to the power minus s minus I t divided by minus s minus I. We'll write the limit minus, now we integrate this term, it will be to the power minus s plus I t divided by minus s plus I. Here we'll also write down the limit separately and we'll use another bracket as this is multiplied with these both terms. We can multiply separately for these two terms, 1 divided by 2i. Now we will write 1 divided by 2i into, if we write the limit inside this function, we will get here for our higher limit e to the power, we write down the limit instead of t. So we will get here e to the power minus this into infinity. So ultimate will be as e to the power minus infinity. We know that the value of e to the power minus infinity is 0. So we'll get for higher limit the value will be 0. And if we put here as 0, then we will get minus e to the power 0 divided by minus s minus I. Now for this term, we have to divide this for both functions, then we will put the limit inside this function. We will get here also e to the power minus infinity, so our higher limit will be 0 and our lower limit will be e to the power 0 divided by minus s plus I. Now we will multiply with these terms. 0 means nothing and this is into minus 1 divided by minus s minus I. Minus 1 divided by 2i into minus e to the power 0 means 1 minus s plus I. So if we remove the brackets, then we will get 1 divided by 2i into 1 divided by s minus I, minus minus plus, and here 1 divided by 2i into 1 divided by s plus I. Now if we calculate this, then s square minus I square as s minus I s plus I, then we will get s square minus I square, and at the upper we will get here from s plus I minus this term s minus I. So the ultimate value will be 2i because this is are cancelled out, and these are, sorry, here will be plus, so 2i, and at the lower part I will get 2i into s square plus 1, because we know that I square equals to minus 1, and for if we put this value we will get s square plus 1. So these are cancelled out and we will get our result as s square plus 1. So the Laplace transform of sin t is equals to 1 divided by s square plus 1. This is used as a formula in different mathematics. And suppose here is our constant term 1. Suppose in another function here our constant term is a t. So then our result will be 1 divided by s square plus a square. Just instead of this lower constant term we will use a. Now let's see the Laplace transform of cos t. Using this similar process, now we'll find the Laplace transform of cos t. Here, just difference between the sin t is here. When we break down the cos t into our exponential term, then we'll get as e to the power it plus e to the power minus it divided by 2. Here is the main difference, but all over process is the same. So at first we will write the basic formula of Laplace transform, which is integrate from 0 to infinity e to the power minus st, and we'll break down this cos t into exponential terms. So we'll write e to the power it plus e to the power minus it divided by 2 into dt, as it is a function of t. So if we remove this constant term from the integration, then we will find integrate 0 to infinity. Now we will multiply this e to the power minus st with these two terms, and we will separate the limit for each term. So e to the power minus s minus I bracket t means we took the t as a common, dt plus integration of 0 to infinity e to the power minus s plus it dt. Now we will integrate these two terms from limiting value 0 to infinity. 1 divided by 2, and for this term after integration we will get e to the power minus s minus I t divided by minus s minus I, and we will put the limiting value 0 to infinity plus 1 divided by 2 e to the power s plus I t divided by minus s plus I, limiting value 0 to infinity. Now if we put the limiting value inside this function, we'll get 1 divided by 2 e to the power minus infinity t, infinity means 0, so 0 minus e to the power 0 means 1 divided by minus s minus I, plus half e to the power minus infinity means 0 minus e to the power 0 means 1 divided by minus s plus I. So if we remove the total bracket, we will get half into minus minus plus 1 divided by s minus I, plus half into 1 divided by s plus I. Now if we further calculate this, we will get 2 into s minus I s plus I means s square minus s square, a plus b a minus, we use the formula of a plus b and a minus b, square minus b square, and at the upper we will get s plus I plus s minus I, and these I are cancelled out, then we will get 2s divided by 2 into s square plus 1, as I square equals to minus 1. Here 2 are cancelled out, so our ultimate result will be s divided by s square plus 1. So we get the Laplace transform of cos t as s divided by s square plus 1. Here 1 is a constant term, and now if we use a as our constant term, means we will do the Laplace transform of cos at, then we will find the result as s divided by s square plus s square. So using the basic formula we can find the Laplace transform of any basic functions. And why we find the basic functions Laplace transform at first? Because the answer of this basic functions Laplace transform will be used as a direct formula in our complex mathematics. So let's see the which formula will be needed for us to solve our complex mathematics. Some formula for Laplace transform. Laplace transform of k equals to k divided by s. We find the Laplace transform of 1, which is 1 divided by s, and this 1 is used as a constant term here k, so we here used k instead of 1, but the process is same to finding the Laplace transform of k. Then Laplace transform of e to the power at, which is 1 divided by s minus a. And the difference between this is here we used e to the power minus at, and in the formula here we used plus. And we already find out the Laplace transform of sin at. Here is a square plus sine square, and the Laplace transform of cos at cos to s divided by s square plus a square. And these are two hyperbolic functions. For these hyperbolic functions, these are same, just difference between the plus and minus sign. Here will be used the minus sign for the hyperbolic function. And Laplace transform of t to the power n equals to, here we have written two formula, but the use of these two formulas are different, they are not same. We discussed about this formula when the n is an integer number, then we will use this formula, and when our n is a fraction number, then we will use this formula. And Laplace transform of c to the power at equals to 1 divided by s minus a log c. This is our basic Laplace transform formula, which will be used further. And these are some algebraic formula which you can see for your better understand. You can find all the Laplace basic functions Laplace transform using the formula of Laplace transform, following the way I have solved the Laplace transform. If you have any questions, then please ask me in the comments.